So solving an equation or inequality that has two different absolute value functions in it can get a little bit complicated. And the reason why is this. When we have two absolute value functions, and I'm just going to draw sort of two random absolute value functions. What are all the possible places for those to intersect? Well, think about it. Each of these two functions has two branches, right? So the green function has a positive branch and a negative branch. And basically what we have to do to solve this algebraically is check to see if this positive branch is going to intersect with either the negative branch here or the positive branch of the other function, right? We also have to check if the negative branch intersects with either of these functions. So what that really gives us, it gives us four cases to check. It gives us the case where this one is positive, where this one is positive and this one is negative, the one where this one is positive and this one is positive, the case where this one is negative and this one is positive, and the case where this one is negative and this one is negative. So it essentially gives us four separate cases we have to check, because there are basically four possible intersections of these lines. Now, a way to get around that is if you accurately sketch these two graphs, you should be able to see which branches intersect quite easily. But here we're going to do the algebraic way. So we're basically going to check each of these four cases. So case one, I'm actually going to erase that to give us a little bit of space. So case one, and that's what I'm going to label it. I'm actually, because we have so many cases here, I'm going to actually label them case one. That is where 6x plus 5, we'll do the case where it's positive and positive. So greater than 0 and 5x plus 6 is greater than 0. So that's the case where both of them are positive, right? So what that's going to look like, it's going to look like positive 6x plus 5 is less than positive 5x plus 6. And we should just be able to solve this inequality pretty easily. X is less than 1. There we go. So in order for this to work, remember, for this to be a solution, it has to work in the restrictions that we gave it, right? And it actually has to work in both restrictions for it to make sense. So let's very quickly check. Does it work in the first restriction? Yeah, because if you plug in 1 there, it's going to work. It's going to be greater than 0. But does it work for the second one? Yep, it actually works for that one as well. So this tells us right away that x is less than 1 is one of the solutions of our problem. So essentially what that's telling us is telling us the positive branches of each of these functions are going to intersect. So maybe I didn't draw it right. Maybe if I was to draw the sketch a little more accurately, maybe it would look something like this, right? Where there is an intersection point of those two functions, right? So let's try case 2. Let's say case 2 is where the first one is positive again and the second one is negative. So 6x plus 5 is greater than 0, but then 5x plus 6 is less than 0. So plugging this in, again, we're just making the first part positive. So positive 6x plus 5 is less than negative 5x plus 6, right? So to simplify that, we're going to get 11x is less than 5, bring that to the other side, negative 5 and negative 6 is going to give us negative 11. Dividing, x is going to be less than negative 1. So does this work if we check it in our cases? Negative 1 plugged into the first case is going to give us negative 6 plus 5, which is not going to be less than 0 or greater than 0. So this actually is not a solution. This tells us that the positive branch of this and the negative branch of this do not actually meet. So clearly I haven't drawn the sketch correctly, or maybe I've flipped the functions around, but either way, the sketch doesn't really help us too much in this case. So let's continue. Let's check case 3. So case 3, let's make that where, I don't know, what do you want to do? Let's make case 3 where the first one is negative, so 6x plus 5 is less than 0, and the second one is positive. 5x plus 6 is greater than 0. Okay, so that would mean the first one's positive, so 6x plus 5 is less than, negative 6x plus 5 is less than positive 5x plus 6. And let's solve this equation. So I'm going to move that to the other side. It's going to be positive, so it's 11x, and then negative 5, negative 6, negative 11. So x is greater than negative 1, right? If we do it like that. I'm going to flip that around, actually, to make it easier. X is greater than negative 1. Write it like that, right? So that's the case there. Now let's check if this satisfies the conditions. So when I plug in negative 1 to my condition here, 6 times negative 1 plus 5, that is a negative number, so that does agree with that. And then 5x plus 6, 5 times negative 1 plus 6, that is a positive number, right? It's positive 1. So it does work there. That means this is actually part of our solution as well, right? So it's basically saying the the negative branch of this function and the positive branch of this function are going to intersect at negative 1. And let's check our last case. That's where both are negative. I know you might be running out of space here, and I apologize for that, but try to squeeze it in. So case 4 is where they're both negative. So 6x plus 5 is less than 0, and 5x plus 6 is less than 0, in which case both are negative. Negative 6x plus 5 is less than negative 5x plus 6. Ooh, so many negatives. This is where it gets confusing for me. This becomes, if I move this 6 to the other side, it's going to become 1x, or just x. And if I move that negative 6 to the other side, it's going to become negative 11. Nope, negative, because it's going to become positive, right? So it's going to become positive 1. So basically, x is greater than 1. So we should check if that satisfies our cases, right? If I plug this in here to the first one, it actually doesn't satisfy it. 6 times 1 plus 5 is a positive number, so it actually doesn't satisfy this. So this also is not a solution. So the two that actually work, the two lines that actually seem to intersect, are the positive line and the positive line, so both of the positive lines, and when the first function is negative and the second function is positive. So those two branches seem to intersect as well. So that tells us our solution should be x is an element of real numbers such that, well, before actually we just jump in and solve it, let's think about it. So it's saying x needs to be greater than negative 1, but less than 1. So it's like saying there's a value between two values, 1 and negative 1, that is true. So it's going to be negative 1, x, 1, right? Now, I encourage you, if you want to check this answer to see if it's right, throw it into Desmos, and you'll see right away that it actually is correct. And the way I drew it is correct, well, roughly correct. I just was talking about the functions backwards. So basically, the two positive branches do intersect there, and then the negative branch of the second function intersects with the positive branch of the first function, and that's this point of intersection right here. So those are our two intersections, and between those values are, well, the values that they intersect at are 1 and negative 1. All right? Feel free to check it with Desmos. This seems like a tedious process, checking the 4 cases, but the algebra isn't complicated. You just have to keep track of everything you're doing. All right?